This is probably the easiest topic that you ever have to do in maths. But then most students, they don't get it right. So now a part of the reason why they don't get it right is that they don't nobody communicates to them that the number basis addition, you're actually familiar with it. You're doing number basis since maybe grade 3. Okay, so this is the stuff that you're familiar with. You're doing it since you were in grade 3. You're doing this. Okay, and I'm here to show you why I'm saying that. Okay, I'm here to sustain that claim. So you have 639 plus 683. So these are numbers that you'd have to do, let's say, in grade 3. And then you're saying 9 plus 3, then you get 12, then you leave remainder 2 here, you carry 1. And here you're saying 8 plus 3, you get 11 plus 1, again you get 12, you leave 2 remainder, which is 2 is the remainder, and then you carry 1. And then here you have 12 plus 1, 13. Okay, then you'd write like this. Okay, so in actual fact, what you do is you get 13, then you say 3k, k1, and then here you'd say 1 plus something, then you get 1 here. That's what you'll be doing. Okay, why do they tell you to k1 this one? What does it mean exactly? And determining that now is very important to you understanding now how to do number-based calculations like 153 base 7. This one you read it as 153, by the way. You don't say 153. So 153 base 7 plus 216 base 7. What would be what is it exactly that's different there? Well, if you want to know what's different, then you have to understand why they were telling you to k that stuff and to leave a remainder. What they were doing there was that it was 9 plus 3, then you get 12. 12, this 12 now, you'd be having one set. The set is obviously of 10, okay? Then you'd be having remainder 2, because one set of 10, it simply means you'd be having 10. And then you'd be having remainder 2 here. So you'd always have to take the remainder, and then you'd k the set. Okay, so similarly here, you'd be having 12 again. Then you'd say one set of 10. The sets, that's what you have to k. That's why we're carrying 1 here, as in you're carrying one set. Okay, and then you're leaving the remainder, which is 2. For this one, it was 13. So you'd say 13, it's equal to one set of 10. That's what you were doing. You just didn't realize it. And remainder 3. Okay, so you'd leave the remainder, which is 3 here. Then you say 1. Then 1 here plus nothing, it's simply 1. That's how you were getting 1, 3, 1, 3, 2, 1. Okay, so now I'm here to show you why this is not even different than if you're working with any other base. And then we'll be using this. What number of sets are we carrying? We're carrying 10. We're carrying sets of 10. Why? Because we were in base 10 here. That was what was happening. Okay, so every number that you're doing in primary school, those were base 10 numbers. Now the difference is that now you have to calculate, these are base 7 numbers. Okay, so base 7 numbers, it means that you have to carry sets of 7. Okay, so carry sets of 7. That's what it means here. Sets of 7. So for example, it's 1, 5, 3 plus 2, 1, 6. You can even do it the way that I'm doing it exactly, because it brings some clarity. You won't go wrong. Okay, so let's say for instance 3 plus 6, you get 9. So you get 9 on the side, and then 9 means how many sets of 7? It means 1 set. This time we're dealing with sets of 7. What's the remainder? The remainder is 2. Okay, 2 remainder. I'm using this as remainder. Okay, so we are leaving the remainder here, and then we are carrying the sets. The number of sets for our case is 1. Okay, so here you get you have 5 plus 1 plus 1, you get 7. So 7, how many sets do you have of 7? You have 1 set of 7. How many sets do you have? How many? What's the remainder? If you take 1 set of 7, obviously you have 0 as a remainder. You don't have anything left. So obviously you take 0 here, then you carry. So 1 plus 1, you get 2. 2 plus 4, then you get 4. 2 plus 2, you get 4. Okay. So you have 4 here. How many sets of 7 do you have? 0. Okay, you have 0 sets of 7. And then you have remainder what? Remainder 4. And that's why we would write the remainder here. And that's it. So 153 base 7, it's equal plus 216 base 7. You get 402 base 7. Okay. That's what you have to do only, and it's not different than what we're doing here. Just observe, 9 plus 3, you get 12. So how many sets do you have of 10? You have 1. That's why we're carrying the set. Here, 1 plus 3, you get 9. How many sets of 7 do you have? You have 1. That's why you're carrying the set. You're carrying the set according to the number base, okay? According to the number base. So here we got 7. 7 means 1 set of 7. That's what we are carrying. We carry the sets. And then the remainder, that's what we write. And then here you get 4. 4, that means 0 sets of 7. So you're not carrying anything. And then you have to leave the remainder, which is 4 for our case. And then that's it. There's no, if you see how I was doing it here and how you have been doing it traditionally since grade 3, it's not different than this. The only difference is now you're carrying sets which are different according to your number base, and you're also leaving the remainder in the same way. Okay, the only difference is what sets are you carrying. Okay, and then the other guideline is that if you are in base 7, you never see any numbers which are 7 here. If you're in base n, you always find n minus 1 and downwards numbers. So base 7 simply means you have the digits there. They are 6, 5, 4, 3, 2, 1, 0. These are the digits which should be permitted, which should be permitted, or which would be legal for expression of any number in base 7. Okay, that means that you never find 7 there. Let's quickly move to let's give another example, a second one. Okay, so second example. So second example says add in base 2. Okay, so we're adding this. So 1, 1, 0, 1, 1 base 2 here, and we're supposed to add 1, 0, 1, 1, 0, 1. Okay, so how many digits? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, we're good. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so make sure that at least for these ones, each digit is aligned with another digit. Okay, and we are working in base 2 like this. So our answer is going to be in base 2. So we're saying 1 plus 1. Then you get what? You get 2. So 2 means how many sets of 1? How many sets of 2? You get 1 set of 2. And then the remainder would be 0. Okay, so this is why we have to write the remainder here as 0, and we have to carry the 1 set of 2 that we have. Here 1 plus 1, you get 2 again, which means 1 set of 2, which we are going to carry, and remainder, which you are going to write here. And here it's also the same thing. We are going to carry 1 set, because this one 1 plus 1 plus 0, you get 2. So 2 means 1 set of 2, which we are going to carry, and then the remainder, which we are going to write here. So write the remainder 0, and then carry your set. Then 1 plus 1 plus 1 means 3. 3 means how many sets of 2? How many sets of 2? You get 1 set of 2, then 1 would be the remainder. Okay, the remainder would be 1. So you're leaving the remainder here, and then you're carrying your set. So 1 plus 1, you get 2. So we have this case again. So leave your remainder, which is 0, and then carry your set. So 1 plus 1, you get what? You get 2. Leave your remainder again, 0. This part is critical. You don't write 2 here just because we said for any number base, the numbers which should be permitted are 1 less than the number base and going downwards. So the numbers which will be permitted for our case would be 1 and 0. So here you'd be saying 1 plus 1, then you get 2. Then you go again and do this and say, okay, I have 1 set of 2 and I have 0 remainder. So that's why I put the remainder 0 here. And then you're carrying your set to the next value here. So this one would be simply 1 plus 0, which is 1. And then you're done. Okay, this is not very difficult. It's the same as what we're doing here. This one was in base 10. This was on base 10. This one was in base 10. What we're doing essentially was 3 plus 9. Then you get 12. Then you say how many sets of 10? How many sets of 10 do you have? Why 10? Because we're in base 10. No, base means base 10. So we have 1, and then we write the remainder, and then you carry forward just like that. Okay, these are not limited to just these two numbers, by the way. You can even have addition of more numbers than two. Let me show you. Let me just quickly delete this. So let's say you have 1 5 3 base 6 plus 1 4 5 base 6 plus 4 4 4 base 6. Let's say you're asked to add all these values. What would you do? Okay, so here you'd get 3 plus 5 you get so 8 plus 4 you get 12. I'm sorry. So here 4 plus 5 you get 9 plus 3, then you get 12. Okay, so 12 means what? We are in base 6. How many sets of 6? You have 2 sets of 6. How many remainders do you have? 0 remainder. And then all you have to do now is to write your remainder. Your remainder for our case is 0. How many sets do you have to carry? You have to carry 2 sets like this. So you'd say 4 plus 4, that's 8 plus 2, then you get 10 plus 5, then you get 15. Okay, so you get 15 here. So it's 2 plus, then you get 7, 7 plus this, then you get 11, plus 4, then you get 15. So 15 means how many sets of 6? You're investigating the base 6. So it means you're investigating number of sets of 6. 15 means 3 sets of 6. It actually means 2 sets of 6, okay, up to 12. So 15 means 2 sets of 6. And then remainder what? Up to 12, to get to 15, you need 3. 3 as your remainder, okay? So now you're leaving the remainder, which is 3. And then you're carrying how many sets? 2. Now you say 2 plus 1, then you get 3 plus 1, then you get 4 plus 4, then you get 8. Again, you go, and then you say 8. How many sets of 6 do I have? I have 1 set of 6. And I have how many remainders? 2. Okay, how many remaining? It's 2. So you write 2, then you carry your set. Your set in this case, it was 1. And then you just say 1, and you get 1 here. Okay, so you can do it with any numbers that you'd have. So let's say you can have 4, adding 4 numbers, it's still the same thing. But essentially it comes from this concept here. If you know this concept, then it's easy for you. Just understand why we carry the sets here. We carry sets just because we're in base 10. In any other base, it's not different. The only difference is that you'll be carrying the sets for the number base. So for example, here we'll be carrying the sets for the base 6. If it were 2 here, you're carrying the sets for the base 2. Only that. Okay. So this is it for addition. So you can find some questions. We'll also try to put, because now we have our website, it's up. So we'll also try to put some questions also on number bases so that you can practice on your own. So primaEd.com, you can go and then find some quiz there. I think we already put some quiz on. We are still to put on geometry, which we did yesterday. We are also still to do another video on geometry, but we put, I think, for some other topics as well in maths. So just go and then check it out, register, and then use, because it will help you understand some stuff, and then test yourself. It will give you a mark instantly after you've done the work. Okay, so that's it. So let's quickly move to subtraction. So subtraction of number bases. Again, you already know. Where am I getting this from? I'll prove to you. Okay, so here you're saying 2, 2, 3 minus primary school stuff, 186. Okay, so if you needed to subtract this primary school stuff, what would you do? So you'd say 3 minus 6. Then you'd say it can't. In Zimbabwe, we say that it can't. That's how we teach our students. And then when it can't, it means that you have to give 10 here. So you'd have to put 1 here. And then you would have to cancel this one and then make it 9 here. And then you'd read this as 13. 13 minus 6. 13 minus 6, what do you get? You get 7, okay? So because 7 plus 6, you get 13. And then here you'd say again 2 minus 9. You'd say that it can't. Then you'd have to put, whenever you put this one, then you cancel this one and then increment it by 1, you increase it by 1. So you'd say 12 minus 9, then you get what? You get 3. then here you get 0, so you'd get 37. But why were we doing this? Why were we doing this? Okay, so I want to show you exactly what we were doing. So here they were just telling you cancel this, cancel this, cancel this, because they thought you would understand if they actually told you what you were doing. Okay, so here I'm just going to put this demarcation here so that you know that these are different. Okay, so let's say you have 2 and then you're subtracting 6. It can't. So you have to give 10 here. That's what will be happening. And then this one becomes 13. Why are you giving 10 here? Because you're in base 10. Okay. This is what was happening. It was very convenient for you to just put that 1 here and then read it as 13. But what you were doing was that you were adding the set. So you're adding the one set which is equal to 10 elements according to 10 numbers according to your number base here. And then you'd cancel this one, and then this one becomes 9. And then this one is if you put 10 here, if you put one set here and then you give 1 here, it means that you haven't upset the balance of your answer. Okay, you're just making it convenient for yourself. That part I won't go into detail much, but essentially what you did here by giving this 10, which results in 10 plus 3, which is 13, is the same thing here. You also increased by 1. This one, it was 186, now it's 196. It means you also increased by 10 here. Okay, so here you'd say 13 minus 6, then you get what? You get 7. And then here again you'd say 2 minus 9, then you'd say it can't. We are in base 10, so this one would be, you would have to add 10 here, then this one becomes 12. So you'd say 12 minus 9, then you get 3. And then whenever you increment here, you should do this in the subsequent steps. When you give 10 here, which is one set, you should also give 1 here so that they remain some balance. So here you'd get 0. So this is why we're getting 37. Okay, we were in base 10, so we're giving 10 here. Let's see how the same method could be used for base 7 calculation. You're subtracting, and this is base 7. 6 minus 5, you know already, right? 6 minus 5, it's simply 1. So we don't have that case where we say, it can't. No, it can. 6 minus 5, it's simply 1. Okay. But then this one now, 3 minus 4, we can't. Okay. So what do? You have to put one set here. One set of what? Of 7. So it's 7 plus 3 here. Okay. So it actually becomes 10. Do you get it? When we couldn't do anything, for example, when we couldn't say 3 minus 6, we added one set here. We're adding set of 10. So that became 3 plus 10. Here we're adding one set, but then it's a set of 7. So it becomes 3 plus what? Plus 7. So 3 plus 7, you'd have to cancel this and then write the result of 3 plus 7, which is 10 for our case. And when you do this, you have to cancel this one and then increment it by 1. Okay, so this subsequent step is the same. So the subsequent step, you just increase the next value, the next digit in the other number by 1, only that. But then here, the crucial thing is that add the number of, according to the number base. So the number base was 7, so you say 3 plus 7, which is 10. So here you say 10 minus 6 minus 4, 10 minus 4, you get what? 10, you say 10 minus 4, 10 minus 4, you get what? You get 6. Then 5 minus 3, you simply get 2. Okay, so this is it. So here, the analogy here, or what's similar with what we're doing in grade 3, was that we were adding, we were just not told, but then we're making this 1, it simply means that it was 3 initially, now it's 13. Why? Because we've added one set of what? Of 10. Why? Because we're in base 10. So if we're in a different base, we should add according to that base. If it's base 7, it should be 3 plus 7, then you get 10 here. Okay, so I'm going to work out another question. So I'm going to work out another question which is different than this. And then maybe we could have another different question as well, a third one, so that there's some clarity. So the next question would be this question right here. Okay, so subtracting base 5. So you have 1, 4, 2, 3. This is in base 5. Okay, so my threes are very lousy. Let me write them properly here. So this one would be 3. Okay, so 4, 2, 4, base 5. And then you're asked to do the subtraction. Okay, so you'd say 3 minus 4. You'd have that scenario, it can't. So when it can't, you have to add one set here. One set of what? Of 5. So it'd be 5 plus 3, which is equal to 8. In the same sense, that would add one set here of 10. Okay, so you'd say 8 minus 4, then you get 4 here. If you increase this one by one set, you should increase this one by 1. Single one. So this one just becomes 3. So now we have a scenario where in the next column here, we have 2 minus 3. Again, it can't. So if it can't, you have to increase this one by the number base. So here you're putting in one set, which is 5 plus 2. You get what? You get 7. So 7 minus 3, you get what? You get 4. And when you increase here by, you should also increase here by 1, a single digit. So here you have 4 minus 5. Again, it can't. So you have to increase this one by number base, which is 5 here for our case. So 5 plus 4, you get 9. So 9 minus 5, you get what? You get 4. And then obviously this one you increment, and then it becomes this. Okay, so don't forget your number here. So this is exactly similar to what we're doing here. Here we're incrementing by the number base. So here would be having 3 minus 6. It can't. So we have to add a 10 here, such that it's 10 plus 3, then becomes 13 here. So 13 minus 6 then becomes 7. This is what we're doing. And so on a number basis, they're very simple. And also the other stuff that we'll cover later on about number bases is that we have to cover conversion. So conversion of number bases from, let's say, base 10 to other bases, and also from other bases to base 10. We have to cover those things. And also there is algebra involving number bases. Okay, so algebra involving number bases. You can have, let's say, 11 base x here equal to something, and then you're asked to find the value of x there. They're also relatively simple. They're also not very difficult math to work through, so we also cover that. But then essentially this is what we do in addition and subtraction of number bases. Okay, so in subtraction, just come from a place of familiarity. And right now I have a challenge for you. Sometimes when you see me doing some of these things, you think, oh, maybe they're easy, just because I'll be doing them. It's very different than if you're doing it yourself. Okay, so I want you to work through some of these questions. And in working through some of these questions, just go to the start of the video. You see a question, then you work it out on your own. See if you get the answer, because we have to make sure that at least you're prepared. When you're in the exam room, you'll be able to do it on your own. Okay, and then also just visit our website, primaEd.com. Okay, on our website you'll be able to find. I'll make sure that by end of tomorrow I'll have put questions on number bases where you can practice. You can input your number. You can do your question, then you put your number, and then it will mark for you, and then give you an instant answer, and then you can revise on the questions that you didn't do well. Okay, on. So yeah, that's it. So we'll also be doing very soon. We'll also be doing a second set of questions on geometry. So I hope that you're psyched about that. Yeah, but then essentially for number bases, this was it, and I hope that you find it easy. If this was helpful to you, make sure you like, share, and subscribe. So I'll catch you in the next video. Yuba out.